It is not safe to power a 50-watt spotlight from a 230 volts 30 amps air conditioner receptacle using 10/2 wire. The primary reason is a voltage mismatch. The air conditioner receptacle supplies 230 volts, while the spotlight is designed to operate at 120 volts. Connecting the 120 volt spotlight to the 230 volt circuit would likely damage the fixture, potentially causing it to burn out immediately or create a fire hazard. Furthermore, 10/2 wire is not rated for use with 30 amp circuits like the air conditioner receptacle. Typically, 10/2 wire is rated for up to 20 amps. Using it on a 30 amp circuit could lead to the wire overheating and potentially causing a fire. The switch used in the circuit must also be rated for the voltage and amperage of the circuit. A standard light switch is generally not rated for 30 amps and 230 volts. Using a switch that is not properly rated could lead to it failing, overheating, or creating a safety hazard. To safely power the spotlight, it is necessary to install a separate 15 amps or 20 amp circuit with 120 volts power specifically for the spotlight. This ensures that the spotlight receives the correct voltage and amperage, preventing damage and ensuring safe operation. For the circuit between the electrical panel and the switch, it is recommended to use 12/2 wire. This wire gauge is suitable for a 15 amps or 20 amp circuit and can safely handle the electrical load. For the circuit between the switch and the spotlight, 14/2 wire can be used. This wire gauge is appropriate for the relatively low current draw of a 50-watt spotlight on a 120 volt circuit. When selecting a switch, ensure that it is rated for 15 amps or 20 amps and 120 volts. This will ensure that the switch can safely handle the electrical load and voltage of the circuit. In summary, avoid connecting a 120 volt spotlight to a 230 volt circuit. Install a dedicated 120 volt circuit with appropriately sized wiring and a properly rated switch to ensure safe and reliable operation of the spotlight. Choosing the correct wire gauge is crucial for electrical safety. The American wire gauge, abbreviated AWG, is a standardized system for denoting wire sizes. The lower the AWG number, the thicker the wire, and the more current it can safely carry. Selecting the appropriate wire gauge depends on the amperage of the circuit and the length of the wire run. Using a wire gauge that is too small for the circuit's amperage can lead to overheating, insulation damage, and potentially a fire. Common wire sizes and their typical amperage ratings are as follows. Firstly, 14 AWG wire is commonly used for 15 amp circuits. Secondly, 12 AWG wire is typically used for 20 amp circuits. Thirdly, 10 AWG wire is often used for 30 amp circuits. Fourthly, 8 AWG wire is frequently used for 40 amp circuits. Fifthly, 6 AWG wire is commonly used for 55 amp circuits. When determining the appropriate wire gauge, it is essential to consult local electrical codes and regulations such as the National Electrical Code or NEC. The NEC provides detailed guidelines on wire sizing based on circuit amperage, conductor type, insulation temperature rating, and other factors. The NEC also includes tables, such as Table 310.15b16, that specify the allowable ampacities of insulated conductors based on their size and insulation type. It is important to consider voltage drop when selecting wire gauge, especially for longer wire runs. Voltage drop refers to the decrease in voltage along a wire due to its resistance. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and other electrical equipment to malfunction. To minimize voltage drop, use a larger wire gauge, which has low resistance, or shorten the wire run. The NEC provides guidelines on voltage drop and recommends limiting it to no more than 3% for branch circuits and 5% for feeders. When working with electrical wiring, always disconnect the power at the circuit breaker before starting any work. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If unsure about any aspect of electrical wiring, consult a qualified electrician. Proper grounding is essential for electrical safety. Grounding provides a low-resistance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All electrical circuits and equipment should be properly grounded according to local electrical codes and regulations. Grounding is typically achieved by connecting the metal enclosures of electrical equipment and appliances to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode is then connected to the neutral conductor at the service entrance, creating a complete grounding path. Ground fault circuit interrupters, abbreviated GFCIs, are devices that protect against electrical shock by monitoring the current flowing in a circuit. If a ground fault occurs, meaning that current is leaking to ground, the GFCI quickly trips the circuit, interrupting the flow of electricity and preventing electrical shock. GFCIs are commonly required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor receptacles. Arc fault circuit interrupters, abbreviated FSIs, are devices that protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating heat and potentially igniting nearby materials. FSIs detect arcing faults and quickly trip the circuit, preventing a fire. FSIs are commonly required in bedrooms and other areas where people sleep. When installing or modifying electrical wiring, it is essential to follow all applicable electrical codes and regulations. Electrical codes are designed to ensure the safety of people and property by providing guidelines for the installation, maintenance, and repair of electrical systems. Local electrical codes may vary depending on the jurisdiction, so it is important to consult with local authorities or a qualified electrician to ensure compliance. Electrical permits are often required for electrical work, especially for new installations or major modifications. Permits ensure that the work is inspected by a qualified electrical inspector to verify compliance with the electrical code. Before starting any electrical work, check with your local building department to determine if a permit is required. When selecting electrical components, such as circuit breakers, switches, and receptacles, ensure that they are listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that the component has been tested and meets certain safety standards. Using UL-listed components helps to ensure the safety and reliability of the electrical system. Electrical boxes are used to enclose and protect electrical connections. Electrical boxes are available in various sizes and materials depending on the application. Metal boxes are typically used for wiring in metal conduit, while plastic boxes are commonly used for wiring in non-metallic sheath cable. When selecting an electrical box, ensure that it is of the correct size and type for the application and that it is properly mounted and secured. Conduit is a protective tubing used to enclose electrical wiring. Conduit is typically made of metal or plastic and is available in various sizes and types. Metal conduit provides excellent protection against physical damage and is often used in commercial and industrial applications. Plastic conduit is lightweight and easy to install and is commonly used in residential applications. When installing conduit, ensure that it is properly supported and secured and that all connections are made tightly and securely. Wire connectors are used to join electrical wires together. Wire connectors are available in various types, including wire nuts, push-in connectors, and crimp connectors. Wire nuts are the most common type of wire connector and are used to twist wires together and secure them with an insulating cap. Push-in connectors are easy to use and provide a quick and reliable connection. Crimp connectors are used to join wires together using a crimping tool. When selecting wire connectors, ensure that they are of the correct size and type for the wires being joined and that they are properly installed. When working with electrical wiring, always double-check all connections to ensure that they are tight and secure. Loose connections can cause overheating, arcing, and potentially a fire. Use a screwdriver or other appropriate tool to tighten all screws and terminals. After completing the wiring, test the circuit to ensure that it is working properly. Use a multimeter to check the voltage and current and to verify that the circuit is properly grounded. If any problems are detected, troubleshoot the circuit to identify and correct the issue. Proper electrical safety is essential to prevent electrical shock, fires, and other hazards. Always follow safe work practices and consult with a qualified electrician if you have any questions or concerns. Remember to always turn off the power at the circuit breaker before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment. Never work on electrical wiring in wet or damp conditions. Avoid overloading electrical circuits. Do not run extension cords under rugs or furniture. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Install GFCIs in areas where there is a high risk of water exposure. Install off-size in bedrooms and other areas where people sleep. Have your electrical system inspected regularly by a qualified electrician. By following these safety tips, you can help to ensure the safety of yourself and your family. When working with electricity, it is always better to be safe than sorry. If you are not comfortable working with electricity, consult a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before starting any electrical work. The NEC is updated every 3 years, so it is important to use the latest edition. State and local electrical codes may also have additional requirements that must be followed. A qualified electrician will be familiar with the latest codes and regulations and can ensure that your electrical work is done safely and correctly. In addition to following electrical codes, it is also important to use good workmanship practices. This includes using the right tools and materials, making neat and secure connections, and properly supporting and protecting wiring. Good workmanship practices help to ensure the reliability and longevity of your electrical system. If you are hiring an electrician, be sure to check their credentials and references. A qualified electrician will be licensed and insured and will have a proven track record of providing quality work. It is also a good idea to get multiple bids before hiring an electrician. This will help you to compare prices and services and to choose the best electrician for your needs. Electrical work can be dangerous, so it is important to take it seriously. By following safe work practices and consulting with a qualified electrician, you can help to ensure that your electrical work is done safely and correctly. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always take precautions and follow safe work practices when working with electricity. Electrical safety is not just about protecting yourself, it is also about protecting your family and your property. By taking the time to learn about electrical safety and to follow safe work practices, you can help to prevent electrical accidents and to keep everyone safe. It is important to remember that electrical codes and regulations are constantly evolving. New technologies and materials are being developed all the time, and electrical codes are updated to reflect these changes. This is why it is important to stay up to date in the latest electrical codes and regulations. One way to do this is to attend electrical safety training courses. These courses can provide you with the knowledge and skills you need to work safely with electricity. Another way to stay up to date on electrical codes is to subscribe to electrical industry publications. These publications often contain articles and information about the latest electrical codes and regulations. You can also visit the websites of electrical safety organizations such as the National Fire Protection Association or NFPA to find information about electrical codes and regulations. By staying informed about electrical codes and regulations, you can help to ensure that your electrical work is done safely and correctly. And as a final note, electrical work must be done by someone qualified and familiar with the relevant standards, codes, guidelines, and regulations.